Hey guys, today we're going to be talking about systems of equations again, but now we're going to be working with the substitution method. So the reason we have different methods is because all of the graphing that we talked about in class um, came out to be nice, pretty numbers. Okay, those two lines crossed at 2 comma 3, the two lines crossed at -3 comma -5. But we know that that doesn't always happen. And in the graphing method, what happens if those two lines cross and you can't actually tell the exact location that they cross? So this is why we have a different method called substitution. So get a piece of paper out if you don't have one already, label your notes, systems of equations, substitution method. Going through here and working on the first problem here. Okay, substitution method. What happens if the solution to the system is not an integer? So the first thing we want to do is solve for a variable, get it by itself. And we're going to talk about how to pick which variable would be a good idea. We want to then substitute it into the other equation, solve, and then substitute your answer into either original equation so that we end up with an x comma y point as our solution. So hopefully you wrote that down. If you didn't, pause the video and write that down. And moving on to our first example here, we have x equals 2y and then 7y minus x equals 15. So our first step that we talked about was to get a variable by itself. And you can see that we already have that right here with x. So what's going to happen is that we're going to substitute. X equals 2y. So this 2y is going to get substituted into my other equation for x. So I have here 7y minus 2y equals 15. So notice how I only have one variable here. I only have y. So 7y minus 2y is 5y equaling 15. Divide by 5, and I get y equaling 3. Okay, so I have part of my solution already. But in order to get my other part, I need to take this 3 and I need to substitute it back into either equation. So if you look here, which one's going to be simpler? Probably substituting into this one here. So x equals 2y. I'm going to plug in my 3 for my y. So I get x equaling 6. So that gives me a solution of 6 comma 3 as an answer to this system. So again, if you'd want to graph this just to check your work, you could graph this even in your calculator, get them into slope-intercept form, and you should get a solution of 6 comma 3 as your answer. Okay, moving on to the next example here. We have y equals a negative 4x plus 8 and y equals x plus 7. So again, we want to get a variable by itself. If you look, both of them are already by themselves. So again, I'm going to take this and I'm going to substitute. This is y, so I'm going to substitute it in for y. So I'm really going to have a negative 4x plus 8 equaling x plus 7. And now from here, we can just solve the equation, right, like you guys know how to do. Subtract your 8, divide by your negative 5, and you get x equaling a 1/5. Okay, so now looking at this, if you wanted to turn this into a 0.2, you're more than welcome to do that. You can keep it as a decimal because it's a nice, pretty number. So now that I have x equaling a 1/5 or a 0.2, I need to plug it back into one of my equations up top here. Again, choose wisely. Right, this bottom equation here is probably going to be easier to substitute it in. So I'm going to substitute in there. So I get y equals a 0.2 plus 7. And then I get y equaling 7.2. So my actual solution here is 0.2 comma 7.2. Oops, not 5.2. So if you think about that, if you would have tried to do this one graphing by hand, there's no way that you could have actually gotten an accurate answer. Right? You can check it on the calculator. The calculator should be able to give you this solution, but actually graphing it by hand would not have worked. All right, last one we're going to do together here. 3y plus 2x equals 4 and negative 6x plus y equaling negative 7. So our first job here is to get a variable by itself. Well, you can see this is the first one that neither one of my equations are y equals or x equals, so we need to do the work. Okay, looking, there's an obvious choice here. There should be an obvious choice of which variable we want to get by itself. And hopefully you're looking at this second equation here because of the y. Notice how there's nothing being multiplied by the y. So this would be very easy to actually get by itself. So I can add my 6x. So now I have y equaling 6x minus 7. Okay, so now I can go and take this is y, and I need to substitute it in to the other equation here. So I'm going to have 3 times 6x minus 7, and then continue with the equation, plus 2x equaling 4. Go and solve. Okay, add 1, and divide by your 20, and you should get x equaling 1.25. All right, now again, we are not done yet. Taking this x equals 1.25, I need to substitute it into either one of my other equations here. It doesn't really matter which one. Okay, I'm just going to pick this second one here just because I want to. So I'm really going to have a negative 6 times a 1.25 plus y equaling 7. And I get here a negative 7.5 plus y, negative 7. Add your 7.5 to both sides, and you should get y equaling 0.5. So my actual solution here is a 1.25, comma, 0.5. Again, if you would try to graph that by hand, there's no way we could have actually gotten that as our answer, but you can check it in the calculator. All right, so this next one, I want you to please try it on your own. So pause the video, and I want you to please try it out. All right, so hopefully here you can see you actually paused the video. You have here, I decided to take my top equation and get the x by itself. I then substituted that back into the second equation, did all my work here, got y equals a 1.75. I then took that y equaling 1.75 and substituted back in. I decided to substitute it back into the first equation here, and I got 2.5. So my solution is 2.5 comma 1.75. All right. Last problem that I want you to please try on your own. So again, pause the video and go through and solve. Okay, so hopefully you pause the video here. So looking, hopefully you really were paying attention to this top equation here. You could have gotten either variable by itself. It didn't really matter. I just chose to get the y by itself because that's what we're used to doing. So I moved the x over. So I got y equals negative x, then took my negative x and substituted it in to the second equation here at the y, solved, and I get x equaling negative 1. Then took that negative 1 and plugged it back into that first equation. Again, you could have plugged it into the second one. It doesn't really matter. And then going through and solving, and you get a solution of negative 1, 1. So hopefully, guys, that actually made a little bit of sense to practice. Okay, your job is to now complete the tic-tac-toe worksheet that was given to you in class. If you can't find it, I also posted it in Google Classroom. You are choosing any 6 problems to complete using substitution. Please don't do all 9 of them. Pick any 6. Make sure that when you're submitting your work, you're submitting all of the work that you did, and it's also numbered so that I can see which ones you actually did. Please make sure you're submitting by the due date that's posted. If you have any questions, please make sure you're emailing or reaching out through a Zoom session. Have a good day, guys. See you in class later. Bye.